We might do some fun things after that. Fun math things. That won't be fun for you, maybe, Brayden, because they're math, but I'm hopeful. We're going to learn how to, all the different ways that we can solve, meaning find the zeros. The zeros you're going to see on the x-axis of the graph. So we actually learned some ways to identify the x-intercepts before. It has to do with the intercept form that we learned last chapter. So the very first thing you should know is some vocab. So the zeros of a quadratic function, they are the x values of a quadratic function that make y equal 0. So when will you know I'm asking for these? When you see the equation set equal to 0. That's all that's saying. So we haven't found this yet, but if you plug something in for x, I'll tell you what the answer is. If you plugged 1 in for x, or 2.5 in for x here, let's get a calculator and do it. Let's plug 2.5 in for x. So 2 times 2.5 squared plus 3 times 2.5 minus 5. I'm going to hit enter. You ready? Mm-hmm. What does it say? Oh, uh-oh.
15.
Did I not do that right?
It says 15.
It does say 15.
See?
Mrs. McDonald. Show that x equals 2.5. No, it doesn't. Let's try 1. Let's try 1. 2 times 1 squared plus 3 times 1 minus 5. Oh, 1 works. I don't know what's the 2.5. We're going to have to talk to her about that. It might be minus, yeah, I don't know. It must be minus 25 or something. Okay, do you see when I plugged it in, it equals 0? So we're going to go through ways this chapter. How do we find those? That's essentially what we're doing. Okay. What? You can't see what?
The calculator.
See it now?
That was delayed.
So the zeros of a quadratic function, here's another way I'm going to ask for them. What's the solutions to quadratic equation? This is another way of saying the same thing. So if I say to solve the quadratic equation, I'm asking you to find where they equal 0. Here's the thing that you probably are the most familiar with, the x-intercepts of the quadratic function. Can you identify where that is on this graph? What does it look like to you on this graph? Looks like a half, x equals 0.5. What else? It also looks like x equals 3.5. So where the x-intercepts are, those are the things that make the quadratic function 0 or solve it. So we're just doing something that we did already and applying it to solving. I think I mentioned this word before, roots. Roots is just another vocabulary word that means x-intercepts or solutions. So if you see that word roots, that means the same thing. So the gist of this page, all 4 of those vocabulary words mean the same thing, but they're just in a different context. Okay, here's the cool thing. Some of them are going to be already factored for you. So, hey, look at this. What's that?
That's it there.
Yeah, what's it called?
Factor.
Shane, you don't want to miss this. Intercept form. We did this already. Intercept form gives us the x-intercepts. So if something's in intercept form, haven't you already identified x-intercepts? So really that's what we're doing today. We're identifying the x-intercepts, which also happen to be where the function equals 0. So let's say I ask for the x-intercepts of this. Wouldn't I need to get it to that form? All right, let's factor it. I don't think you need your factoring pair sheet, but maybe you want one, so if you want to come grab it. Can somebody help me out here with factoring x squared minus 6x plus 5? So 5 and 1, you're very close, would
30.
add up to positive 6. What should I make them to add up to negative? Yes, negative 1 and negative 5. And then I just put these x's in front. Now, remember x is a liar for intercept form. So what are the actual x-intercepts of this?
1 and 5.
Yeah, 1, 0, if I was looking at an ordered pair, and 5, 0 are the x-ins. Okay. Oh, we already did that. What are the zeros of x squared minus 6x plus 5? Same question. Right? Because doesn't it make it 0? They are. We found it above. 1, 0, and 5, 0. Okay. So let's say something is already in factored form for you. Then you can go right to the x is a liar part. And who asked me before why x was a liar? Did anyone ask me that? Nobody in this class did? No? The reason why x is a liar is because what you're actually doing on these is you're setting x minus 1 equal to 0, because I'm trying to find where it's 0. Solve that for me. What would that be?
1.
You'd add 1 to both sides. X equals 1. And if I said, hey, x minus 5 equals 0, would you add 5 to both sides? So x equals 5. So that's why x is a liar in those, because you're really finding what makes them 0. So the cool thing is, if it's already in factored form for you, you don't have to do the factoring part. Let's take a look-see.
Look-see.
Look-see. Hey, we first have to make sure that these they have a 0 over here. If they don't, then we're going to show that we got to just move that to the other side. Then what we do is we take our factors and we set them equal to 0. Or you can just remember 0 is a liar. How about the 4 in front? Doesn't matter. Because this means 4 times something is 0. And so what we know then is either x plus negative 2 has to equal 0, or x plus 3 has to equal 0 in order to make that true. All right, solve the first one for me. Solve this. Do we need the parentheses there anymore? Nope. What would I do to both sides? Add 2. X equals 2. What would I do to both sides here? Not add 3, subtract 3. X equals negative 3. Now, sometimes I might have to use the solving steps that we've learned before. All right, so I have this times this equals 0. It's already factored for me. So if I want to find where that happens, I have to set both parentheses equal to 0. So we're going to do 2x plus 1 equals 0. And 5x minus 3 equals 0. I wish there was a little bit more room here, but I can write small. Can somebody tell me the 2 steps in order to solve this?
How do you solve it?
That's what I'm asking. What would I do first? Here, minus 1 from both sides. So we got 2x equals 1. Now what? Divide by 2. X equals 1/2. All right, that's one of my answers. Let's do this guy. What would I do first? Add 3. 5x equals 3. Now what? Divide by 5. X equals, you can write it as a decimal. I'm going to just leave it as 3 over 5. So we're just solving those.
Have we done this before?
Yes. We're kind of just putting 2 steps together, the factoring and the solving.
Didn't we like subtract the x instead of the y now? Or whatever?
What do you mean?
What is it equal?
Remember?
3 over 5. All right, sometimes it's okay if we see more than 2. This one has 3 things that I have to set equal to 0. So let's do the first one, 5x equals 0. If you divided both sides by 5, wouldn't we just get 0? What's the next parentheses?
2x.
Okay, I'll draw a little line here. Let's set 2x minus 8 equal to 0. Good. Add 8 to both sides. Now what? X equals 4. There's one more parentheses because each of these things could be 0. X plus 7 equals 0. What do I do to
Minus 7.
just minus 7? So how many solutions does this have? Because this is what we're doing. We're solving with factoring. There's 3. X equals 0, x equals 4, x equals negative 7. If you put any of those in for x, they would give you an answer of 0. Okay. You want me to do the next one?
Sure.
How many are there on the next one?
3.
4.
There's 4 of them.
Oh, I guess.
Well, three of the solutions you hardly have to do any work to solve. What's the solution of x plus 8 equals 0? I think we can do that without x equals negative 8. What's the solution for this one?
Positive 3.
X equals positive 3.
Positive 5.
Okay. And this one we have to do a little work. Just a little. What would I do first?
Minus 7.
Good. Last. Divide by 3. And just leave it, honestly. I'm cool with you just leaving it. Negative 7/3. What was it, approximately negative 2.6 repeating, I think. 2.3 repeating.
Can I do the work?
Yeah,
Okay.
Negative 2.3.
So, these were all factored for you. Now we're going to just put 2 steps together. Then we'll do some whiteboard practice. I think we need to do some whiteboard practice. Yeah. All right. Oh, man, no parentheses. That's okay. Get your factor pairs out. Let's factor it first.
11. So it's times up.
We factored this one earlier on in class.
Then it'd be
Negative 3, negative 8.
Now we're going to factor first and then do what we just did.
Negative 3, negative 8.
Negative 3 and negative 8.
dumb.
X minus 3, x minus 8, that's how I'm factoring it, equals 0. Now do what you were just doing. So if x minus 3 equals 0, what would x have to be? Add 3. X equals 3. Put a box around that because there's a lot of work. I'm going to box my answers. X minus 8 equals 0.
X equals 8.
You're going to add 8 to both sides. X equals 8.
Oh, yeah, that makes sense.
Okay.
Hard.
It isn't hard. So you just want to check, I want to point out to you to see how there's a 0 there. We're setting them equal to 0. We're setting them equal to 0. We're setting them. Okay, now you might think, well, I should just factor and set it equal to 5. Well, that's not quite as easy because the 0 product property is special. If you have like 15 things multiplied together and only one of them is 0, it makes it 0. There's a lot more things that multiply to be 5. I don't want to deal with that. I just want to deal with 0. So really easy thing. How would I make that a 0? I'm gonna just move it to the other side, and then I'm gonna have something that's easy to work with. So let's rewrite this. This would be n squared plus 7n, and now what is this last term? 10. And then that equals 0. Okay, get your factor sheet out. Or just take a look. Multiplies to be 10, adds up to be 7. 2 and 5. So n plus 2, n plus 5 equals 0. So make sure, don't write 2 and 5, it's tempting. This really means n plus 2 equals 0. So what would I do to both sides? Minus 2, n equals negative 2. N plus 5 equals 0. Subtract 5, n equals negative 5. Would you like to do one more of those together, or would you like to just practice doing that on a whiteboard?
Whiteboard.
Okay, go grab one.